Man, I am so honored to be here. I have such a tremendous amount of respect for Eric and what he's done with the company and what all of you guys have done with the company. It's amazing to watch the technology. I was just talking about, I've written a couple of books. One of the books that I've written is called Automated Lighting, the Art and Science of Moving Light. And the first edition came out in 2003. And it took me 3 years to write it. I would sit down, like I'd wake up in the morning, I'd sit down and I'd write for 1 hour, and I did that 365 days a year, Christmas included, for 3 years, and at the end of 3 years I had a book. And in 2010, I revised it. And the revision took about 6 months. I updated the pictures, and I updated a little bit of the information, and that was the second edition of the book. Well, in 2015, my publisher called me up and she said, it's probably time you revise the automated lighting book again. I said, yeah, that makes sense. So I started digging into it and started rewriting like the first couple of chapters. And every time I'd look into it, I found that the technology had changed. And so I'd have to go and re-educate myself about the new technology. So I found myself going to different schools. I'd go to hog classes, and I'd go to grandma classes, and I'd go to Verilight school, and I'd go to this school and that school. And it ended up taking me 3 years to revise, and it was painful. It was painful because every aspect of it had changed, but that's a good thing because the technologies are, the capabilities are so much greater now. But, the parts that have stayed the same are very few. Everything's changing, so which means that we're all challenged to keep up with the technology, and that's why it's a good thing that we're all here together, and we're going to share each other's experiences, and feel free to contribute. A lot of you that are here know more about this stuff than I do. I'll tell you this, I'm not the smartest person in the room. I am the best looking, but I'm not the smartest. So this is a group effort. We're gonna go through this material together. We're gonna talk about it. We're gonna explore. We're gonna learn. And we have a fabulous opportunity here. Look around you. We're surrounded by technology, and we've got access to all this gear thanks to Eric and Elation and the whole company, and people like Sean back there, who's at the console. So we're going to, now I brought some handouts. Most of you have them. I know we're short. We're getting some more going now, so hopefully in the next, before the next couple of hours, everybody will have a handout, okay? So this is your guide to what you're gonna see up here, and it's also your place to take notes. And I recommend that you take notes, and when you take notes, think about what's gonna happen 5 years from now. When you go back and reference your notes, you're gonna wanna be able to decipher them, so take enough notes that you understand what you're talking about, okay? Now, so what I'd like to do, so this is your class, it's not my class, it's your class, right? And I wanted to make sure that you get what you came here for. And in order to make that happen, I'd kind of like to get an idea of what you expect to get out of class. Now, what I'd like to deliver is, when you walk out of here, I hope that you'll know more about all of the control protocols and technology, DMX 512-A, which is the current protocol that we use for lighting control. RDM's kind of new. Well, I say that it's actually been around since 2006, but it's only gaining traction right about now, and a lot of people are starting to use it. And it's a fabulous tool to have in your tool belt. I use that metaphorically. It's not really like a wrench, but it is a wrench in a way. It's a software wrench, if you will. And we'll talk about wireless DMX. Wireless DMX is making huge strides. If people will tell you, some people in the industry will tell you, well, if you can hardwire it. But I'm of the opposite opinion. I say, if you can use wireless DMX, use wireless DMX. And there are people in our industry who don't entirely trust wireless DMX, probably because of bad experiences they had 20 years ago when the technology is nothing like it is today. The technology has evolved and changed, and it's gotten so much better. And you know, within the last 5 years, there's been huge changes in that area. It's gotten cheaper, it's gotten more reliable, more accessible, easier to use. And if you understand best practices, if you understand how wireless works, you have a much better chance of getting it to work reliably, you know. So we want to talk about what those best practices are and what that means. So we'll talk about that. We'll talk about, and of course, one of the biggest changes in the industry is that computers are getting cheaper. You've heard of the Internet of Things, you know, where everything is basically now a computer and it's all connected to the Internet. You know, I bought a Ring doorbell a couple of weeks ago, a video doorbell. And now when somebody rings my doorbell, I get a notification on my phone and I can turn it on. I can look, you know, even if I'm in LA, I can see what's going on in my hometown in Austin, you know, on my front porch. And everything soon will be connected to the Internet. And as a result, not only are processors getting cheaper and wireless devices like Bluetooth and Wi-Fi and wireless DMX getting cheaper, but the technology is getting more accessible, which means that it's going to find its way into all of this gear. You know, it won't be long, I predict, and you know, I have no inside knowledge of this, but I predict that in the near future, the lights will know their exact position in space, in 3D space. They'll know their trim height. They will, you know, they already have temperature sensors in them. They might have other sensors as well. There was a company in the UK, they've since gone out of business, but they were very innovative, and they were making products that had built-in sensors in them. They made this one product called an LED, which was an LED strip, and it, you know, LED, E-L-I-D-Y, was a kind of a play on words, you know, LED. It was a strip of 8 RGB LEDs, and it was very small, like the size of a, I don't know, a cigar, except longer, right? And had the 8 pixels on it, RGB pixels. And it had a touch sensor, and it had an orientation sensor. The touch sensor was, because the fixture was so small, there's no room for a menu display to change the DMX address. So the way you set the DMX address is you connected them all to the controller, you turn on the controller and put it in address mode, and then you would touch the fixtures in the order that you wanted them to self-address themselves. So through touch sensor, you know, they did some clever things. And then also, because the thing had no real orientation, you couldn't tell if it was right side up or upside down. If you mounted one way and the other way, it knew. And so if you tried to chase them, it knew the proper order to chase the pixels to make a linear chase because of the orientation sensor. So if you take those kinds of things and you put them in this technology over your head, you can get some incredible things to happen, you know. But it's going to, so, and what that's doing is it's changing all of our jobs because, you know, if you think about it, in the early days of man, when we lived in caves, our tools were sticks. You know, we had spears, we had clubs, right? And then as we evolved, our tools became made out of stone. We fashioned hammers and scrapers and dart points and arrowheads. And then in the industrial age, we learned to forge steel. And so we had steel tools like wrenches and screwdrivers and saws and hammers. You know, a hammer, by the way, it's still my favorite tool of all time, you know, because it does some great stuff. And then in the 1960s, when we started getting electronics developed, then our tools became more electronic. We had oscilloscopes, we had voltmeters, and that kind of stuff. Now, in the lighting world, or even in the audio and video world, you know, when we develop new protocols like DMX, well, we have to develop new tools to use to troubleshoot them. So now we have handheld testers, and we have other devices that will help us set up and test and troubleshoot these systems. And so if you think about the way our tools are evolving today we have consoles that are networked together over Ethernet networks, and we're sending Ethernet encapsulated data like ArtNet or streaming ACN or some form of Ethernet-based protocol. How do you troubleshoot that? That's a big challenge, right? How do you see Ethernet traffic? I know how to test analog voltage with the voltmeter. I know how to test DMX coming out of a console because we have handheld devices to do that, like the Swisson. But ArtNet, streaming ACN, Ethernet protocols are presenting us with an all-new challenge. And the solution is software-based. You know, there are applications that you can download and run on your computer, but you have to know how to tap into the network to be able to sniff that traffic and to look at it and figure out what's going right and what's going wrong with it. So that's our big challenge now. So over the next couple of days, we're going to be talking about those protocols that we know and love, like DMX, RDM, wireless DMX. And then tomorrow, if you're going to be, I know some of you are not going to be here tomorrow. We're going to miss you. But tomorrow we'll be talking about how you set up and test Ethernet, how you set up and test Ethernet-based protocols like ArtNet and streaming ACN, which are becoming more and more important because the bigger our systems are and the more complicated the devices are, the more bandwidth they use, the more sense it makes, the more logical it is to use Ethernet-based protocols because Ethernet is way, way faster than DMX. DMX, if you think about it, the baud rate, the rate of transmission of DMX is 250,000 bits per second. And by today's standards, that's really, really slow. Why do we still use DMX today? Well, there was an attempt several years ago to change that. And the result was a protocol called Architecture for Control Networks, or ACN. And it wasn't very successful because it was complicated and it came out, the timing was all wrong. It came out in 2006. In 2008, the economy took a nosedive, and a lot of companies that might have had the resources to implement it were laying people off, and they were stretched thin. So ACN, pure ACN, kind of went by the wayside. So we still use DMX, but you know what? DMX is pretty bulletproof. It's reliable, and if there's one thing we value in our industry over anything else, it's reliability. When we press the go button, it darn well better go. And if it doesn't, then that technology gets thrown off the show and we bring something else in. So over the next couple of days, we're going to have a lot of fun. We're going to learn and explore and play with things and see what we can figure out, okay? Is everybody for that?
Yep.
All right. Let me just get this in here. So, there we go. All right, so if you look around you, you see, this lighting system in here. Now, I don't know specifics about this lighting rig, but I do know in general, when you look at the kinds of shows that you see today, this is a typical kind of system that you might see. Is that you've got your main console and your backup console, right? Now, a lighting console, a video switcher, an audio console is a computer, and computers crash, right? So typically in the lighting world, we'll have a main console and a backup console. And in the old days, to sync them together, because that's important, you want, in order to have a reliable backup system, they should be tracking each other. When you press go on one console, the other one should follow it. So that if one crashes, you can pick up on the other one. In the old days, we used to do that through MIDI show control. So MIDI show control, MIDI is a protocol that's been around since the 1980s, early 80s. And it's very slow, very crude, very basic, but there's a subset of it called MIDI show control, designed specifically for firing cues, and it uses the same cable as MIDI does. It's an 8-pin DIN cable. And so what we do is we set up two consoles and we connect a MIDI cable in between the two. And if you go into setup, you turn on MIDI show control out of one and into the other. And every time you fired a cue, it would send a command to the other console to advance the cue stack. You know, a cue is a list of commands, right? So every time you fired a cue on the main console, it would follow in the backup console. That way, if one computer crashed, if one console crashed, the other one was at the right cue, you could switch over to it. Now, in the old days, we had an A-B switch. So we take the DMX out of one console, the DMX out of another console, and put it into a physical switch. The output was sent by switching over from the A to B. So that was, it worked. Wasn't ideal, but it worked. And so, but today it's done a little bit differently. Most consoles today have the ability, if you can put them on the same computer network, on the same Ethernet network, and you configure them properly, they automatically track each other. There's a lot of advantages to that. One is that when you save your show, you know, to a programmer, that is your livelihood. Your show file is your livelihood. If you lose your show file, you can get kicked off of a show, or you know, you don't get paid, or it's bad, right? So saving your show file is very, very important. So with today's backup systems, typically when you save your show file, it will automatically save it to the main console and to the backup console. Then also, when you play back your cues, then the backup console tracks it, and if one of them crashes, then you don't have to physically switch over because the network will automatically detect. So they make DMX splitters, for example, that have two inputs, an A and a B, and they will detect whether or not there's a signal there, and the one that is active, as long as there's a signal coming in, that will be the active one. But as soon as you lose the signal, it automatically switches over to the other one. You know, so typically have a main console and backup console. It's funny too that in the audio world, is anybody here in audio? Anybody do audio work? Yeah, a little bit. Okay. You also do lighting work too? Okay. In the audio world, they typically don't have a backup console, which just amazes me. Because again, especially now with digital audio consoles, those are just computers. And so they're flying without a net, you know. There's no safety net. Now I think that is changing, and correct me if I'm wrong, but I'm starting to see more and more shows where they do have a backup audio console. In the video world, same thing. I don't think they have backup switchers in the video world. So we're kind of unique in that regard. But it's been demonstrated time and time again that there's a need to have a backup, you know, so it's always a good idea to have a backup. And the good thing is that nowadays with offline editors, it's a real easy thing to do to have a backup. You know, you don't have to have two full-size consoles, although I'm sure Elation would be happy to sell them to you, right? But you could have a full-size console and then the PC version running on a laptop with the dongle to convert the computer output to DMX or to streaming ACN or ArtNet. And so that's a more economical approach, but you still have a backup. So there's nothing wrong with that. So sometimes you have a laptop running your backup. So the output of the console today, so it really depends on the size of your show. If you have a small to medium-sized show, then your console might be outputting DMX, and that's fine. But remember, a DMX cable can only control 512 channels. That's one universe of DMX. And these days, if you look up, it's like, wow, that's a lot of control channels. You know, not only are our systems getting bigger, but every light, every device is using more control channels. You know, if you look, do you guys have any pixel mapping stuff in here? So yeah, okay. And so in the biggest mode, how many channels is it? 72. And which fixtures are those now? 6-bar 1000. The 6-bar 1000. So 72 channels. So that means that you might have 10 fixed, no, not even 10, 6 fixtures per universe. So you can see that you very quickly, you can run out of control channels on a single universe of DMX, which means now you need a second universe of DMX. And if you have a system this size, then chances are you're going to want you're not going to want to run 12 home runs of DMX. And by home run, I mean from the console to the first device. Might be a data splitter or a gateway or a fixture. That's the home run, the longest cable. You don't want to run 12 of them, or 24 of them, or 32 of them. So if you're in a situation where you're using a lot of universes of DMX, then you probably want to move on to ArtNet or streaming ACN or some other Ethernet-based protocol. And the reason is that because Ethernet is so much faster than DMX that you can transport multiple universes of DMX over a single Ethernet cable. How many? Well, it depends on your hardware. It's limited by the hardware. Your hardware, the console has what's called a network interface card, or NIC, and the network interface card there's different variations of Ethernet. You have 10 megabit per second Ethernet, you have 100 megabit per second Ethernet, you have 1,000 megabit per second Ethernet, which is gigabit. So the more bandwidth you have, the more universes it can transport. And if you have a gigabit network, with the gigabit network, you can transport at least 2,000 universes of DMX. And you might say to yourself, 2,000, who would ever use 2,000 universes of DMX? And that's what I would say too. Until a couple of weeks ago, I read an article where there was a show that was using 1,024 universes of DMX, one show. Why? Because of pixel mapping. Pixel mapping, if you're unaware, and by the way, if anybody has any questions at any time, feel free to interrupt me, raise your hand, stop, ask a question. Yes?
Just to clarify or confirm what you said that was on the gigabit transfer rate?
Right.
It was up to 2,000? Okay.
Right. Yeah, so are you going to be, what's your name?
John.
John. Will you be here tomorrow, John?
Yes.
Okay. So tomorrow, we will go over the math and the numbers, and we'll talk about exactly how many universes of DMX you can transport for different types of networks. But the short answer is it's somewhere between 2,000 and 4,000 for a gigabit network. Okay? So anyway, pixel mapping is where you take a video file and you align it to a grid of RGB LEDs. And there's the advantage of that is that it saves a lot of programming time. So if you want a color wave, for example, rather than programming, I mean, in some instances, it's impossible to program. You could not take a big matrix of RGB LEDs. If you had some of those 6 bars, and say you had 12 across and 12 down, that's a lot of RGB pixels. It would take you forever just to program one effect. But if you use pixel mapping software, which I'm sure that the M series has it built in, because most consoles do now, what you can do is you can take a video file with a color wave, and you can map it to that array of RGB LEDs, and it's very quick and simple, and it's really effective. It looks great. So it saves a lot of time. So if you're doing that kind of stuff, you're going to gobble up your universes of DMX, your control channels, so it only makes sense then to use some Ethernet-based protocol. And so to do that, you'd go into your console, into the settings, and you would configure it for outputting your choice of Ethernet-based protocol. Right now, we're kind of in flux, we're kind of in transition, because from 1998 up until fairly recently, almost everybody in that situation would choose ArtNet to output. That's changing a little bit now for reasons that we'll talk about, but a lot of people are switching over to streaming ACN. Streaming ACN is very similar to ArtNet. They do exactly the same thing, but they do it in different ways, and we'll discuss what those different ways are. But a lot of people I know are switching over to streaming ACN for various reasons. So if you are using some Ethernet-based protocol, that means you have to set up an Ethernet network. And the way you set up an Ethernet network is you use a network switch. And I'm sure you've seen network switches before. You know, they have the Ethernet ports on them, and they're usually, you know, rack mounted or whatever. There's all kinds of those, and there's some that are specific to our industry. But a switch is how you build an Ethernet network. And so that allows you then to transport multiple universes of DMX over a single Ethernet cable. And then you can distribute that around the stage, but at some point, typically, you want to convert it from ArtNet or streaming ACN back to DMX, because some lights will only run on DMX. Others, some of the newer lights, will actually take ArtNet directly. I just had a hybrid Proteus the other couple of weeks ago. I wrote a product review about it. And it has an Ethernet connector on it, which means that it takes ArtNet or streaming ACN directly. That also means it has its own IP address and its own subnet mask. What does that mean? Well, we'll talk about that tomorrow. Okay? So a lot of fixtures now, because they take so many control channels, it makes sense for them to take some Ethernet-based protocol directly. But if they don't, like, you know, I would guess the majority of these lights probably don't have an Ethernet port on them. They don't take ArtNet or streaming ACN. That means you need some kind of protocol converter. So there are things called gateways or nodes. And a gateway or a node is a protocol converter. And it converts from an Ethernet-based protocol back to DMX. And the advantage is that, other than the fact that some lights don't take ArtNet directly or streaming ACN directly, the advantage is that Ethernet is what's called a star topology, meaning that you would have to run one cable to every fixture if you're using Ethernet. Now imagine having a console like that, running an Ethernet cable to a big switch with Ethernet ports on it, and then running one cable to every fixture. One cable to every fixture. Look up. How fun would that be? Not very, right? So what we want to do instead is we'll have a box that converts from Ethernet back to DMX, and that's the gateway or the node. And DMX is what's called a bus topology. So that allows you to daisy chain the DMX cable, which is much quicker and easier to set up. It's much quicker and easier to tear down and to load out, you know. So that's typical of what we're looking at today, right? Let's see. Let me check the time real quick. Okay. So before we jump into DMX, I actually got ahead of myself. I meant to do a little kind of introduction of what I'd like to ask you. Oh, thank you. Yeah. So this is a switch. Oh, sorry. No, this is a data splitter. I thought you were handing me a switch.
It's actually the ArtNet, so that's going to be
okay.
A node.
Ah, this is a node. So this is what we call a two-port node, because there's two Ethernet ports, and there's a bunch of. So this is a combined switch and data splitter. So this will take Ethernet in and spit DMX out. Or my guess is probably do the opposite, will it not? You can input DMX and output ArtNet or streaming ACN.
You turn it ArtNet in and then DMX out on it.
Oh, okay. Okay, all right. But there are some that go both ways, right? So, but anyway, so if you're not familiar with the node, this is a two-port node, okay? So this is, this is eNode 8 Pro. Anybody have any idea how much this costs? No salespeople in here? Oh, Red's going to look it up. Okay. Anyway, I got ahead of myself. I meant to ask you to introduce yourself to the class and tell us where you're from. And also, I'd like to know how long you've been working in the industry, so we can kind of get an idea of the level of experience. Because typically in these classes, we have a very wide range of experience in the class, which is great, because the people with less experience the people with more experience can help help out the people with less experience, and the people with less experience can help us old guys know what's current and what kind of music you're listening to and that kind of stuff, right? So